Welcome back. In this module, we're diving into the core of cybersecurity engineering, system design, and architecture principles. Let's explore the essential building blocks that ensure our systems are functional and secure by design.
1.
The principle of defense in depth from the Institute of Security Architecture United. RP4. Imagine you're protecting a castle. You wouldn't just rely on one wall, right? You'd build moats, gates, guards, and towers around it. That's the idea behind defense in depth. We use multiple, overlapping layers of security, so if one fails, others are ready. For example, even if an attacker bypasses the firewall and gains access to the network, layered controls like endpoint protection, authentication policies, and segmentation can still stop them. It's redundancy with purpose, like having backup plans for your backup plans.
2.
The principle of secure by design from the Institute of Security Architecture United are .P5. Now think of building a house. You wouldn't wait until after construction to install locks. You design them in from the start. Secure by design means we embed security from the ground up. From initial architecture to development and deployment, we plan for threats and build defenses in every phase. We anticipate threats early and integrate defensive mechanisms before the system goes live. Take a web application, for example. Input validation, encryption, and access control should be built in, not bolted on afterward.
3.
The principle of minimize attack surface from the Institute of Security Architecture United ARD P6. Every feature, service, or open port is a potential doorway for an attacker. With minimize attack surface, we aim to reduce these doorways. If a system doesn't need a function, disable it. If a port isn't essential, close it. A real-world example, a company left an unused admin panel publicly accessible, becoming the breach point for a major ransomware attack. Eliminating unneeded exposure could have stopped it cold.
4.
The principle of economy of mechanism from the Institute of Security Architecture United ARD P7. Complex systems tend to hide vulnerabilities. The economy of mechanism pushes us to keep security controls minimal and straightforward. Simple code is easier to audit. Fewer features mean fewer bugs. That's why secure APIs often focus on doing a few tasks well rather than becoming bloated with unnecessary features. Less surface is equal to fewer bugs, and fewer bugs is equal to fewer vulnerabilities.
5.
The principle of open design from the Institute of Security Architecture United ARD P8. Contrary to popular belief, secrecy isn't security. Open design means systems should be secure even when their design is public. We rely on proven cryptography and transparent processes, not obscurity. HTTPS is a great example. Its protocols are open and scrutinized globally, making them stronger and more resilient. 6. The principle of fail-safe defaults from the Institute of Security Architecture United. RP9. Let's say a server crashes during a system update. Should it default to letting everyone in? Definitely not. Fail-safe defaults ensure that systems fail in a secure state if something goes wrong. Access is denied unless explicitly allowed. In one real-world case, a system misconfiguration prevented unauthorized access during an outage, thanks to secure failover logic.
7.
The principle of secure default from the Institute of Security Architecture United. RP10. Similarly, secure defaults means systems come with secure configurations that are out of the box. Think about new Wi-Fi routers, older models, shipped with default admin passwords like admin123. That's a hacker's dream. Today, best practices include random default passwords, auto-encryption, and remote access disabled by default. Security shouldn't be optional. It should be the default. Summary together, these 7 principles act like the blueprint for building systems that defend themselves. From layered protection and simplicity to secure failure and transparent design, each principle works toward the same goal: resilience against evolving cyber threats. Remember, the goal isn't just to make secure systems, it's to make security the system. Our next module will explore how governance and policy reinforce and sustain these principles across the enterprise. Stay tuned.